Hi, I'm Sam.
I'm Irene.
I'm Bill.
I'm Hafiz.
I'm Patrick.
I'm Cooper.
And we're Team Brain Drain, and we're here to introduce an exciting innovation in the treatment of hydrocephalus.
Hydrocephalus is a disease where a patient has abnormal buildup of fluid inside their skull. This can lead to all sorts of neurological symptoms, such as trouble walking, impaired cognitive functioning, and in very severe cases, can even lead to death. Hydrocephalus is not a rare disease. In fact, it has been estimated that up to 1 million people in the United States currently suffer from hydrocephalus. So, what treatment options do these people have? Today, doctors insert a drain that connects the inside of the skull to the abdominal cavity. This drain lets the built-up fluid inside the skull escape into the abdomen. This system is called a shunt, and is also the only method currently available to patients with hydrocephalus.
To help visualize how shunts work, we have set up this test stand to represent the pressures in the head and the abdomen. Fluids always flow from a high pressure to low pressure, so in this case, fluid will flow out of the head through the shunt tubing and into the abdomen following a positive pressure gradient. Shunts operate under the assumption that this positive pressure gradient is always there. However, this assumption is not always valid. In rare cases, there's a negative pressure gradient preventing fluid from escaping the brain. In these cases, shunts are not sufficient to allow fluid to escape the skull, and currently there are no medical devices to address this issue. For the past year, we have been developing a new medical device that can address this challenge. We call this device the CephloPump. Through talking with our mentors and sponsors, as well as research into the current market environment, we created a set of 7 design criteria to inform our prototyping process, as well as help guide us through the design of the CephloPump. These design criteria represent the 7 key quantifiable metrics we want our device to meet before we consider it a successful prototype. We organized these design criteria based on the priority they had in influencing our design decisions. The order is as follows: patient safety, robustness, or how easily our device adapts to changes in the human body, size and geometry, accuracy and precision, complexity, or how easily our device integrates into existing shunt tubing, weight, and data transmission speed. Keeping all 7 of these design criteria in mind, we were able to assemble and build the CephloPump. The CephloPump would be implanted during routine shunt surgery, acting as an add-on to any existing shunt system. Near the skull, the surgeon will connect a pressure sensor, which will go in front of the shunt valve. In the abdomen, the surgeon will connect the tubing to the CephloPump. The CephloPump reads the pressure in the head and in the abdomen. From this information, it decides whether to turn on the micropump to assist in pulling fluid from the skull. Here is the micropump. This is where the sensor goes. This is the battery underneath this board here, and this is our custom printed circuit board. And since the device will be implanted, the device is capable of wireless charging. Once implanted, the CephloPump can be connected to another device over Bluetooth using our Brain Drain application. To start the app connection, select the device in the Bluetooth drop-down menu. The application will allow the user to change pressure parameters in order to best address the patient needs. In the Live Data tab, the user can read live pressure data sent from the device. Finally, when the user is done reading live data, they can also save the data to their device. Here's a demonstration of the functioning device. In this scenario, the pressure is too high for the patient to tolerate safely. As you can see, the pressure in the head is gradually lowered and eventually stabilized at the target pressure by the device. When water is added again to simulate a subsequent increase in pressure, the pump automatically turns on and stabilizes the pressure once more.
In conclusion, the CephloPump is a device that smoothly integrates into existing shunt systems and will help treat hydrocephalus by pumping excess fluid out of the brain. It is the first device of its kind that would be able to drain fluid against high abdominal pressures and would allow for accurate continuous pressure readings outside of the hospital setting. With the CephloPump, we can give patients more control over their treatment options and help doctors improve patient lives.